Hey everyone, welcome to lesson 2.8. This is the last lesson of our quadratics functions graphing unit, and then we'll move on to something different. But we've taken a look at two forms of quadratic functions, and one is standard form and vertex form. And remember, we get different characteristics from each form that can be helpful in graphing our quadratics. The third form that I want to introduce you to is called intercept form. And intercept form is called that because it gives you the intercepts. It actually gives you the x-intercepts of the function. Remember what that is? The intercepts are the locations at which the parabola crosses the x-axis. So let's take a look. We go back to the parent function again. All of this work is usually in relation to the parent function, and we see some of our key points, our vertex, 1, 1, 2, 4. So some of the key points of the parent function. And if we look at the graph of y equals x minus 2 times x plus 1, let's say you go to Desmo, so you take a look at that, or if you have a graphing calculator, you'll notice it's a little different. And what happens here is that there are 2 points at which this parabola crosses the x-axis. And it looks like this is -1 and this one is 2. So if you're paying attention, you can see that there's a 1 here and a 2 here. However, they're opposite signs, and that's important to note. So describe the difference between the graphs. A couple of different things. We could describe the difference of the vertices. We can see where the parent function touches the x-axis. So in the first situation, the parent function, it touches the x-axis only once. In our second example, the parabola is shifted down, and now the parabola touches the x-axis twice. So the shape of it, the step pattern, those things are still the same. So let's write in here. The graph of y equals x squared, which is the parent function, it touches the x-axis at 0 only once. The graph of y equals x minus 2 times x plus 1 crosses the x-axis at -1, 0 and 2, 0. We also note that the x values correspond to the opposites of the values inside the brackets. In our next example here, we have y is equal to x minus 2 times x plus 2. And if you go over to look at the graph, you can see that there are 2 points at which the parabola crosses the x-axis, and they are at -2 and +2. and that would correspond with our values inside the brackets. So again, you can make a description here of the difference between the parent function, which is y equals x squared. Again, it only touches the x-axis once at 0. With this function, it crosses the x-axis at 2 points, at -2, 0, and at 2, 0. So I'll let you write that in. If we observe the points at which the parabola crosses the x-axis, these points are called the x-intercepts, which makes sense, right? And they always correspond to the negative of the value that's in the brackets. X-intercepts can also be referred to as solutions or as roots of the function. So you'll see those terms interchangeably as we move forward in the course. So in summary, for a quadratic function that's written in intercept form, y equals a times x minus p times x minus q, the value of a is still the same. It can cause a stretch or compression or flip the graph upside down. It's just the same as in vertex form and standard form. But here, the values of p and q correspond to the x-intercepts of the parabola. And to note here that if the values of p and q are negative in the function, then they are positive on the graph and vice versa. So let's take a look at some examples. Pretty easy here. We have functions given in intercept form, and we want to state what the x-intercepts are. Remember that they are always opposite to the sign that's inside the bracket. So for a, y is equal to x minus 2 times x plus 1. One x-intercept is going to be 2, and the other x-intercept is going to be equal to -1. Always opposite. Over here, for b, x equals 3, and the other intercept is x equals 1. For c, one intercept is x equals -5, and the other is x equals -4. And for d, x equals 8, and the other intercept is x equals -1. Well, what if we want to go backwards and go from the graph to the factored form, or the intercept form? Let's take a quick look here at A. Here we want to be able to see where the graph crosses the x-axis. So these divisions look like they're going up by 2s. So let's say here seems like it's a value of -4. And then here, the other point at which it crosses the x-axis, that looks like it's 3. So knowing that, we just fill it into our intercept form of a quadratic. Now, important piece of information here, we want to assume that a is equal to 1. So that helps us just eliminate the a. And so when I write the intercept form of this quadratic, it's going to be y equals, and we change the signs, x plus 4 and x minus 3. I'll do that a couple more times with you. Here we have an intercept here at -5, and we have an intercept here at -1. And so in intercept form, my function would be written as y equals x plus 5 and x plus 1. Remember opposites. Example C. Take a close look. Oh, that looks like it's the same example. Let's go over to D. Here we have an intercept at -1 and 1. So this is 1, this is -1. And so our function would be written as y equals x minus 1 and x plus 1. So how would we find the axis of symmetry or the vertex for a quadratic function that is written in intercept form? So here we go with our intercept form, y equals a times x minus p times x minus q. So if p and q are the x-intercepts, and we know a quadratic is symmetrical, then the axis of symmetry should fall right through the middle between p and q. So what happens is then that we have to find the middle of p and q. So for quadratic functions in intercept form, the axis of symmetry is located halfway between the x-intercepts, p and q. And so we use this little formula to find the axis of symmetry. So let's determine the axis of symmetry here. So here, remember p and q are opposite. So x is equal to 2 plus -1 divided by 2. Here, x equals 1/2. So that's the axis of symmetry. For b, x is going to equal 3 plus 1 all over 2. So x here is going to be 4 over 2 simplifies to 2. Our axis of symmetry is x equals 2. So this can be done fairly quickly. X equals -6 plus -4. Remember, opposite sides, divided by 2. X gives me a -10 divided by 2. The axis of symmetry is x equals -5. And finally, D, x equals, this is 9 plus -1. That'll give me 8 over 2. The axis of symmetry here is x equals 4. So what do I do with that? Finding the vertex in intercept form. So when you determine the axis of symmetry, you've also determined the x-coordinate of the vertex. That's the same thing as the other two forms of quadratics. So you can find the y-coordinate of the vertex by substituting the x value into the function and then simplifying. We've done this before. So let's say for a that we have the function y equals x minus 2 times x plus 1. And I tell you that the axis of symmetry is x equals 0.5. In order to find the y value or the y coordinate of the vertex, we'll go ahead and plug in 0.5 for x. So y is equal to 0.5 minus 2 times 0.5 plus 1. And y is going to equal -1.5 times 1.5. And y is going to equal -2.25. So the vertex for this function is 0.5 and -2.25. For the next example, we say that the axis of symmetry happens at x equals 2. And so to find the corresponding y value, we're going to substitute that. So y equals -2 minus 3 times 2 minus 1. y is equal to negative, -1, and +1, y equals 1. So the vertex here is going to be 2, 1. So once you get the hang of that and you're subbing in the axis of symmetry into the function in order to find the y coordinate of your vertex. We'll just do it one more time here. Y is equal to 2 times -5 plus 6 and -5 plus 4. Simplifying, y is equal to 2 times 1 times -1. Y here is equal to -2. So the vertex for this function is -5, -2. So let's take a look at graphing functions in intercept form. Once you know the x-intercepts, and you found your axis of symmetry, and you have your vertex, we really only need one other point. So we try to find another point, maybe something that's easy to work with. And so let's take a look at the example that I have for you. I'm going to zoom in on this. So we have the function y equals 2 times x plus 6 times x minus 4. So what I want you to note here is that the two intercepts are plotted here and here. Then to find my axis of symmetry, x equals p plus q divided by 2. So I plugged in my values for p and q here, which was -6 and -4. And I find an axis of symmetry at x equals -5. I plug that into the original function at the top, and I simplify to get y equals -2. That becomes my vertex right here. So I have the two intercepts, and I have the vertex. I really only need one other point in order to sketch my quadratic. And in my situation here, I just decided to use x equals -3. Again, you can choose a different point, but something I just wanted to use that seemed simple to me. So I go ahead and I plug that in. Remember the original functions at the top. And so I plug that in, -3 into the function here. And when I simplify, I get y equals 6. So I plot that point, -3, 6 there. My axis of symmetry comes right down through the middle here. That's x equals -5. And then above, because of symmetry, I can plot this point. So now I have the vertex. I have the two intercepts. I found one coordinate, and then I use symmetry to get the other coordinate. And then I'm able to sketch my quadratic. So there's an example for you. So what I want you to do is, part of the exercise is being able to graph by hand in this way. So give that a try. I want you to graph by hand on graph paper, and then take a picture and see if you can upload the picture to the document, just as I have. Okay. Any questions, again, reach out.